All right, looks like we've got a few coming in.
Okay.
Give it another minute or two, and then we can get started. All right, good morning, everyone. I'm going to go ahead and get started here so we can make the most of our time. So thank you for joining us this morning. Um, my name is Dahlin. I am one of the engineering managers at Printpack, and we are going to talk to you today a little bit about some of the different engineering and technical careers that exist in the manufacturing world. Uh, So one of the things that I do want to note is a lot of the roles that we're going to be talking about here, we're going to be speaking of them relative to our experience with Printpack. However, these jobs are common for pretty much all manufacturing companies. Titles may change a little bit, the division of duties may change a little bit, but every manufacturer needs people performing these tasks. So a little bit about the presenters. You've got Dan Short, who's joining me on the phone. Hi, Dan.
Hello, everyone.
He's the electrical and controls engineering manager for Printpack. He is also a mechanical engineering graduate from Georgia Tech. He's got a background in automation, robotics. I'm Will Dallin. I'm the manager of facilities improvement and support, one of the other engineering departments at Printpack. I'm also a mechanical engineering student from Georgia Tech. I've got a background in automation as well as some oil field experience. A little bit about who Printpack is. We are a manufacturing company that makes packaging. So we make packaging for everything from medical devices to coffee, fruit cups. We have flexible packaging, which you can think of as like potato chip bags, coffee bags, rigid packaging like the fruit cocktail cup that you see on the screen. And we've got about 20 facilities across North America. The map is a little out of date. We actually have a third facility in Mexico now. So the job categories that we kind of want to breeze through really quickly are coming into three main areas, and those are maintenance, production, and engineering. And under each of those, we're going to hit a few different topics. So for maintenance, we'll talk about what mechanics do, what does it mean to be a multi-craft technician, what are electronics technicians, and then the scheduler role, which is far more complex than it sounds. In production, we'll talk a little bit about quality inspection, machine operating, and process engineering. And then on the actual engineering track, we'll talk about mechanical engineering, electrical controls engineering, some of the industrial engineering aspects that we've got, and then there are some more specialty areas of engineering that we'll touch on briefly. So on the mechanics side, right, there's a lot of physical components in manufacturing. Mechanics spend a lot of time working on motors, pumps, and gearboxes, right? You can see some examples of those on the screen right now, making sure these things are aligned and well connected, and continually inspecting and tweaking them to make sure they stay that way. Otherwise, bad things can happen to your machines. They'll spend a lot of time working with piping, valves, pneumatics. It's not always motors that are introducing motion in machines. There's a lot of other different methods to do it, pneumatics and hydraulics being chief among those. So they'll spend a lot of time maintaining these systems, looking for problem components, installing better actuators, gaining different efficiencies throughout. And then there's, of course, the machine assembly and alignment side of things. And while that may seem kind of easy, there's actually a lot of work that goes into making a machine that's 120 feet long be within 1/100th of an inch front to back. So these machines, they don't come in one big piece, they come in a lot of little pieces, and they've got to be assembled very precisely, or your process isn't going to run very well. And it's the mechanics that are doing a lot of that work. Multicraft technicians, machining parts is a big thing that they do. So if you have a multicraft technician in a facility, something specialized on a machine breaks, you're probably going to call this person out to the machine. They're going to figure out what this part is, and they may have to build it from scratch. You may be grabbing a raw chunk of metal and coming out with a very special bracket or bearing housing. You'll see a lot of welding and fabrication. So what we've got an example of here is some ductwork, and if you look at the top, you can see these welds on this ductwork. And welding thin metal like that is actually extremely difficult. Welders go through a lot of training. They're very specialized workers, and there's a lot of science that goes behind how they're able to do what they're able to do. And you can see here, like it's critical. If that was a flexible member of ductwork, it would not be able to maintain its position well enough. It would collapse, it would bend, it would affect the airflows. So things like that have to be made out of something rigid, which means they're going to have to be welded. And then, of course, there's the rebuilding of complicated mechanical devices. What you see here is what's called an AODD, or an air-operated double diaphragm pump. So this is a pump that uses compressed air to then pump a fluid. And you can see in the exploded view down below, there's a whole lot of different parts that are part of these things. And of course, nothing lasts forever. So it is very common for these to break down and to need repair, and to need to be cleaned out and rebuilt. And it's a multi-craft technician that typically jumps on and handles those. You have the electronics technician side, and these guys handle everything from power wiring, circuit breakers, switch gears, which is what you can see the guy in the picture dealing with right now. These are think of them as very, very large circuit breakers and transformers. You'll see him repair automated equipment. So what you're looking at now are a couple pictures of electrical panels from some of our production equipment, and you can see that there's a lot going on in there. And these electrical or electronics technicians are doing everything from troubleshooting the machine behavior to testing different aspects on the machine to try and find which wire came loose. You'll also see them troubleshoot machine behavior. So here's a shot of an automated line, and if this automated line starts doing something unexpected, the electronics technician is called out to the line to examine it and watch the behavior and determine what sensor is failing, what input to the system was wrong, why is the machine behaving in a way that was not expected. So scheduler and lead, we've talked about a couple different positions in the maintenance department, and these maintenance departments can range anywhere from 12 to 30 people depending on the size of the factory. And while you're trying to repair the different production assets, you don't want to do it while they're necessarily running. You've got to find what we call downtime, which is time in between the machines making whatever the actual product is to get in and do the work. So the scheduler or maintenance lead is the one that coordinates with production to do that, and that can be a very complicated process. They're also generally in charge of finding specialty parts. As all of these machines are designed and built, the engineers that design them choose very specific parts for very specific reasons. And just looking at the number of bolts that are on the market, you can kind of get an idea of how complicated some of these parts can be. There's thousands and thousands of bearings that you can order, for example, and you've got to make sure you've got the right one. It's got to have the right shape. It's got to have the right number of rolling elements. It's got to have the right lubricant, and that can become a little tricky to manage. So you've got some help there with your scheduler and lead, and then of course maintaining repair records. The more often a machine breaks down, the more often you're probably going to need to take it down to investigate further as to why it keeps breaking down. You don't ever want to just fix a symptom and stop there. You want to do what's called a root cause analysis, find the actual underlying problem and address that. And you're never going to find the underlying problem if you're not keeping records. So jumping a little bit to the production side of things, quality inspector, of course, this is critical for pretty much all manufacturers. You need to know that what you're doing, what you're making, is actually what you intended to make. Does it meet the specifications that the customer asked for? You'll use specialized equipment to test the tear strength of the packaging in our case. How easy is it to peel? Does it braid? Does it abrade? Is it sealing the way it's supposed to seal? And you'll often get into cause and effect studies to determine why things aren't meeting the specifications that they're supposed to. Is it a machine setting? Was there a problem with the raw material? Did it sit too long on the shelf? Was the test performed incorrectly? All of these things the quality inspector's got to be involved in. Of course, there's the machine operator, and this is the person who is actually running the production equipment. They are the first line of quality assurance, and they are the ones that are optimizing the actual functioning of the machines. So what you're looking at in this picture is an example of a large web-fed printing press. And these can operate at thousands of feet a minute. And it's the operator that's controlling that machine to make the product that the customer has ordered. They've got some tools available to them, like here's a vision system. This is a scanning camera that moves up and down the printed material and is constantly comparing pictures it's taking with what is supposed to be printed. So we have an understanding of where the machine might not be meeting its expectations. And of course, there's plenty of screens across these machines for the operators to examine not only how is the product being made, but how is the machine itself performing, and are there any problems occurring with the machine. Within production, you also have process engineering. And here you can see a bit of a flow chart that is kind of typical for process engineers. They'll break down the entire production process. They're going to look for ways to optimize it, because not only does that make things faster, it makes them more efficient, and it makes them cheaper, which means more profit. They'll test method of productions. Sometimes that's done in small pilot plants. Printpack actually has a small pilot plant out in Villarica, Georgia, where we're constantly testing different material mixes and different ways of producing our products. And they'll get involved in very complex quality issues. So if your quality supervisor that we talked about a moment ago is kind of running into a brick wall or is having trouble tracing things back, the process engineer may take over, because there may need to be a broader scope of the investigation to find out why your product isn't what it's supposed to be. On the engineering side, we're going to start out with mechanical engineering. So these engineers are often the ones that are speccing the motors, pumps, and gearboxes. So they're looking for the right combination of gear and motor to produce a certain amount of torque or power in order to move a device. And that device is going to be something like a pump, a blower, a conveyor belt, a grinder, um, all kinds of fun things. They'll also get involved in piping valves and pneumatics. So here you can see what's called a P&ID, or a process and instrumentation diagram. And this houses basically all the actuators and sensors that are being used in a particular process and indexes them so that you can refer to this drawing and go back to your original engineering design criteria and make sure that the process is properly designed, or you're going to then get involved with some of the quality concerns that we've been mentioning and investigating where the process is breaking down. They also do HVAC, which is heating, ventilation, and air conditioning, which sounds pretty simple, but try and provide air conditioning for a 60-story skyscraper, right? This is something that can get very complicated very quickly. And in production environments, you can have very narrow ranges of humidity and temperature where your process is performing adequately. So it is very critical to have the correct environment for your machines to operate. And mechanical engineers are the ones that provide that. On the electrical side, you have the obvious power wiring, circuit breaker, switchgear. So what you're looking at here is an example of what's called a one-line drawing, which is basically how electrical power is distributed through a facility. And it's going to include transformers, circuit breakers, disconnect switches, load information. And the electrical engineer is making sure that not only is all of that following the correct code so it's safe and legal to operate, but it's going to be sufficient for the equipment. On the control side, you'll see them get into PLC and drive programming. So PLC stands for Programmable Logic Controller. You can think of this as the brain of any particular machine. So in production environments, in manufacturing facilities, we're not using things like Arduinos, or Raspberry Pis. We've got very specialized, industrially hardened controllers. And some of them are programmed through what we call ladder logic, which actually has a very interesting history that I would recommend you look up on Wikipedia if you're curious. And you can see a little snippet of ladder logic code down at the bottom. They'll also get involved in sensor selection, and this could be a sensor anywhere from a safety scanner, like the area scanner you see at the top, to a hydrostatic pressure sensor, which you see at the bottom. You can use the hydrostatics for tank depths, and of course the safety laser scanner is checking to make sure that nobody's getting too close to a moving robot or any type of moving machinery where they could be at a safety risk. The industrial engineering side does a lot with material handling. So industrial engineers are looking at how much product is being produced from a machine, what shape is that product in, how is it being handled, meaning how is it moved throughout the facility? Is a person carrying it? Does it need to go on a pallet? Is it going on a forklift? Where does it need to be stored? What kind of warehouse capacity do you need? And they're mapping all of this on the plant layouts to make sure that the products and the raw materials can actually move through the facility without creating little traffic jams that slow things down. They'll do machine capacity studies also. So here's an example of one that's happened over the course of a year, and it's studying how much is actually being produced on a particular machine versus what is this machine fully capable of. And that gives the industrial engineer some idea of what we call machine capacity, which is how much can we make on a particular machine. So now I know, can I load this machine up more, or am I running at its limit? They'll get into process optimization as well. For the industrial engineer, the process is not necessarily the manufacturing process. itself, it's how the material moves through the manufacturing process. So how is raw material brought in? How is it then stored? How is it moved to the first machine? How is the the work in progress from that first machine moved to the second machine, and so on until you get your final product and you're ready to send it out the door. Um, some specialty areas of engineering, there's loss prevention engineering, which what you're looking at in this picture is what are called risers. And these are part of a fire suppression system in a factory. So all of the sprinklers that you see overhead are being fed by these risers. And to make sure that they're constantly ready to go in case of a fire, there's certain things that these engineers are looking for, and that's flow rate and pressure primarily. And those have to be constantly monitored to make sure they're present. So you can see the different dials and gauges that are available on these risers so that somebody can walk by and check and make sure that, yeah, okay, I'm still safe. If something were to happen, my sprinklers will work. There's energy engineering, and this kind of comes in two different flavors. One is the energy sourcing side, and this is where am I buying my raw energy? Am I buying natural gas? Am I buying electricity? If I'm buying electricity, am I getting it from a coal plant, from a nuclear plant, or from a renewable source like wind or solar? Um, the next side of that is, am I efficiently using my energy? Um, we talked about pneumatics earlier. Well, pneumatics rely on a supply of compressed air, which means there is a device creating this high pressured air volume. That air compressor can be incredibly inefficient. And if there are any leaks throughout the facility, then you're creating compressed air that you're not using for anything useful. And that's just wasted money. So the energy engineer is in charge of making sure that the energy that we get is used in a responsible and effective way. So prevent leaks, use efficient components, and make sure where you can you're pulling from renewable sources. There's reliability engineering also, which nothing lasts forever. Everything breaks eventually. The trick for manufacturing is to know when do you expect it to break, and if you can figure out when you expect it to break, can you get ahead of it and go ahead and repair or replace this part before it breaks? Because it is much easier to plan the machine downtime and go in and effect your repairs than it is to wait until something breaks and now you're in crunch time trying to get a product out the door and your motors fail. So all of these different areas have some amount of professional licensing and certifications. So on the maintenance sides, there's licensing for electricians, for welders, for millwrights being people that do like machine alignments and heavy movement of equipment. And then there's certified machinists also who are fabricating parts. Each of these licenses and certifications has different levels. Each of these levels speak to what's called a minimum competency. So based on somebody's license and certification, what you can expect them to know in their technical field. It's a little difficult to know everything about a person, so we compensate for it with licenses and professional certifications. On the engineering side, there's of course your degree. Some engineers choose to go in and get what's called a professional engineering license, which is backed typically by the state. So if you're in Georgia, it would be the state of Georgia that you register with as a professional engineer. And that gives you the legal right to stamp a drawing, which means you have done an examination on it and you have determined that it is fit and safe for use. In order to get to the professional engineering license, you have to first be an engineer in training, which requires no professional experience, just a degree, and then there's an exam to take. Uh, and a lot of engineers will find through their career that the amount of time they spend crunching numbers, so to speak, becomes pretty small relative to the amount of hours that they work. And that's because they get into what's called project management. So it's not enough to simply draw the platform that you want to build. You also need to know what material you're going to use, where you're going to source that material, who's going to assemble it, when is it going to be installed, when will it be ready for use. So there's much more to all of these engineering endeavors than just the engineering itself, and all of that generally falls under the project management. So there are project management specific certifications that you can get. All right, so as promised, we ran through that pretty quickly, and the hope is that you guys have a lot of questions because it is very difficult to condense the wide array of professions that are available in engineering into an hour. You know, you hear about SpaceX and you hear about Tesla and all of these other real fun engineering disciplines, you know, in the news and in social media. However, there's a massive world of technical fields beyond those. We're hoping that we brought a little bit of awareness of that to you today. So any questions?
To the attendees, if you're having difficulties, there's a Q&A in the chat for you to type, but there is not an unmute feature for the person for asking questions.
Will, you mentioned a few companies that are in the news recently. What sort of processes at Printpack, for example, would you run into at a company like Tesla for maybe the Tesla battery manufacturing process?
Well, for sure, you're going to run into some very precise welding. You know, these battery packs are built of lots and lots of little cells that have to be anchored together, and that's typically done through welding. So there's some very critical welding that happens there. There's also a lot of the same industrial engineering principles of how am I moving my material around? How do I perform these thousands of welds on a particular part in the fastest way possible? So the parallel to us in Printpack is generally how do I get my material into the building and then moved efficiently from the machine so that I'm not standing at my machine for an hour waiting on somebody to drop off the next set of material.
I'm noticing a question from one of our students. What kind of certificates do PE folks get? I believe he's referring to professional engineering.
So the PE itself is the license. So when someone says they are a PE, that means they are a licensed professional engineer. And the way that you get that is typically you've got to pass what's called the FE exam, which is Fundamentals of Engineering. And you can take that as soon as you've graduated with your engineering degree. And then there's a certain amount of professional experience that you're required to have. And I think it's around 4 years of professional experience. Once you have the 4 years, then you can apply to the state. And if the state accepts your application, you are then allowed to take the PE test, which is just another test. And if you pass that, you get your license. The PE test is generally a bit more narrow in scope than the FE test. So the fundamentals of engineering, you're taking just straight out of your undergraduate or graduate education. And it's just broadly speaking about engineering in general. They are divided into like electrical engineering, computer engineering, mechanical engineering. But within each exam, they're pretty broad because they're expecting you to come to that test mainly with just the knowledge gained from the coursework. When you get to the PE level, they're going to be more narrow because they're going to expect you to be working from a knowledge base based on your professional work. So I think there's about 6 or so different versions of the mechanical engineering exam or the electrical engineering exam. But then once you get those and you get your PE license, there's not like a next level to the PE.
So if I'm a mechanical engineer and I want to pursue a professional engineering certification in electrical engineering, something outside, is that an opportunity?
There is an
Or
opportunity for that. It depends on the state you're in. So the state of Georgia will actually tell you which of the PE tests you're going to take, and they're going to base that on your actual professional experience. So when you apply to take the PE exam, when you're applying for your license with the state, they're going to ask for your work experience, and you're required to provide a certain number of references, and these references are going to validate your work experience. And then the state's going to assign you a test based on what that work experience is. So if you graduate with a mechanical engineering degree, you take the mechanical engineering FE exam, then you get a job working for, well, let's say Georgia Power, and you're designing power distribution systems for the next 4 years. When you apply for your PE test, you're going to say, hey, I've been working for 4 years under Georgia Power doing all this power distribution work. And the state of Georgia is going to say, okay, you can take the test, but you're going to be taking the electrical engineering test. And then once you get that PE license, you're not confined to that discipline. So if you get your PE in, say, power distribution systems, right? Well, a PE license is a PE license. You can go stamp whatever drawings you want to stamp. The catch is you are under an ethical obligation to make sure that it is an area that you are competent enough in to make that determination. So at
Great.
that point, it
There's
kind of comes down to the engineer.
another question. Is there typically an increase in pay for those who earn a professional engineering certificate?
Broadly speaking, yes, but it depends on the industry. And an easy example there is, you can go and be a mechanical engineer working on bearing design, which is a actually very fascinating field. Um, and you could get a PE, but it might not really mean a lot to your employer. Say you happen to have a PE in mechanical engineering, you're designing bearings, there's not really a PE requirement for bearings. They may not give you too much of a pay bump. But on the other side, there's other disciplines like civil engineering where if you don't get a PE, you're going to be capped out at very low levels of your profession for the entirety of your career. Because so much of what civil engineers work on has a safety element that nobody really wants to employ somebody who doesn't have that PE license, that hasn't shown that minimum level of competence. They view it as risky. So in that case, you're almost required to get a PE. And then there's other sides too, where say you have a PE in electrical power distribution systems, and you're working for, let's go back to the Georgia Power example. They have some pretty complicated power distribution problems. They need that expertise. They want people that have that license that can validate their work, and you're going to get a more substantial pay bump there. So broadly speaking, yes, you do get a pay increase, but how much of that increase you get depends on the industry that you're in, and then your actual job category within that industry.
So we talked a lot about engineering, but there were also some of the other technical roles that don't require a 4-year bachelor's degree. What sort of education track would lead us towards, I don't know, if someone was interested in being a machinist?
So there are some high schools that actually have machinist skills development programs within them, and they can come out of high school with some of the certifications that are required. There's also technical colleges. I believe University of West Georgia has some around fabrication, and there's the opportunity for the associate's degrees from there, which are the 2-year degrees instead of the 4-year bachelor degrees. And that'll give you a very strong leg up. And then there are more uh, schools that are more specific to those areas. Like you'll see advertisements on TV here and there for there's a motorcycle maintenance um, training program, right? So, you go there and they teach you what you need to know. Again, we're kind of back to this idea of minimum competence, and once you've reached that minimum competence, then this organization basically says, hey, you're allowed to use our name to say that you know this stuff. So there's a bunch of different ways to do it. Some of the ways are actually just starting out. If you want to be a machinist, you find a machine shop that you want to work at and you start working there and you determine, what do I need to be successful in this machine shop? Am I going to be working mainly on manual mills and lathes? Do I need to learn CNC? Am I going to have to learn electric discharge machining? And you can use that to kind of guide your way through the specialties. But as far as minimum required education, it's generally a high school degree. And then depending on the level of specialization from there, possibly an associate's degree.
So what is an associate's degree?
An associate's degree is a 2-year degree available at many technical colleges. And it's kind of an accelerated program that focuses your learning very specifically in certain areas. So if you go in and you want to get, say, an associate's degree as an electronics technician, from day one, they're going to be putting you in front of actual equipment, and you're going to be studying and working on this equipment versus, say, a bachelor's degree where you're going to spend the first 2 years building general knowledge before you start focusing in on a particular engineering discipline. So you can think of it in a sense that an associate's degree is kind of a very hands-on, specialized version of the last 2 years of a bachelor's degree.
So I had a question, so if that's okay.
Go for it.
So kind of in the realm of college, if one wanted to find internships regarding these processes and organizations to get some experience on them before they actually graduate, what would be the best way for them to do that?
Well, it's a couple different ways you can go through that. Most schools these days have pretty strong relationships with companies nearby. So for example, at Georgia Tech, they host a number of career fairs throughout the year where you can go and talk to different people from different companies and get an idea of what this company is, what they're looking for, and what opportunities for internships may be available. There's, of course, the online searching. You can go to places like Monster, Indeed, LinkedIn, and get an idea of who's hiring interns. But it's also a good idea to go straight to the company's website too. So for example, printpack.com, you can go there and you can pull up our job listing and you can see where we have available co-ops and internships.
Sorry, Will, I just wanted to emphasize again that your school will have, a college or would usually have a well-established program to help students match up with internships and co-ops available in the area or even out of state. It's becoming more and more common now, at least since when I was in school back in the 90s, for just about every engineering student to have an opportunity, or at Georgia Tech even possibly a requirement to have some internship or co-op experience in their course.
And so we mentioned internships and co-ops there, so I want to distinguish those a little bit. So an internship is typically a one-semester engagement with a company. So for example, if you were to come work with me as an intern at Printpack, I would expect you to be there for basically a semester. So around 3 to 4 months total. And that would be more or less the end of our engagement. Co-ops are, you can think of them as recurring internships. So you would come in and work, say, the spring semester, then you'll be in school for the summer semester, then you come back and work for the fall semester. And so you're coming back to the same company, and it gives you the opportunity to develop within that company and develop your skills. And the companies are generally a little more willing to, you know, invest in your training and spend more time teaching you because they know you're going to come back. Internships, on the other hand, are generally a little more project dependent. So if you're hired on as an intern for a company, there's a good chance they're going to have a very specific project in mind for you. And that's what you're going to be working on through your internship because they're not necessarily expecting you to return. Both are excellent programs. Which you choose kind of depends on where you want to go and what you want to do. And, you know, if you happen to have a pretty good idea of what you want to do, then, you know, co-op is a great way to cement that and get a head start on your field because you have that recurrence. You know, if you've got a lot of uncertainty around what you want to do, maybe you want to try an internship here and there, and that kind of spreads you out a little bit.
I didn't want to beat this horse too much, but it seemed like such a good question. I wanted to just go ahead and say that there's also opportunities for students in high school to do job shadows for possibly a week to get some idea of what somebody does during their everyday activities. Maybe you can see some of the we were talking about manufacturing. Maybe you can see some of the manufacturing systems. Maybe you could see the office environment. So there's some opportunities as well.
Thank you. And well, I had another question, if that was all right.
Sure.
So obviously these are very competitive businesses and fields and jobs, and so the path from where we are as students to there can be full of ups and downs. So I guess if you had a single piece of advice or just something to keep in mind as we as students kind of move forward to college with the goal of ending up at these jobs, what would that be?
Well, I would say when I started at Georgia Tech, I wasn't sure what I wanted my major to be. I went in as undecided engineering. I was on the fence between computer science, aerospace engineering, and mechanical engineering. And I ended up selecting mechanical engineering. And most of my career was spent working on what today are called mechatronic systems. So not a lot of traditional mechanical engineering. So my advice would be, don't let what your major is become too much of a sticking point for you, because that's what I did. I spent a lot of time thinking about what do I need to major in because I'll be stuck in that field forever. And that's not necessarily the case. If you're out and you're interviewing and you can show that you have skills in other areas, you know, there's nothing stopping you from working in those areas. You know, Dan is a mechanical engineering, has a mechanical engineering degree, but is managing the electrical and controls engineering group. I've got a mechanical engineering degree and spent 6 years as an electrical and controls engineer. So don't sweat too much what your degree is, but think more of what do you bring to the table with these companies? You know, what are your proven skills? What cool projects have you worked on while you were in school, and what was your role on those projects? How do you bring what you learned on those projects into the company to benefit the company?
Yeah, I would add to that, my piece of advice is to try and learn as much as you can, take every opportunity to pursue classes that are outside your major specialty as well. Because you know, technology is becoming more of a blurred line between electrical and mechanical, computer science, industrial engineering. The skills that you can pick up or ways of approaching problems vary between the disciplines. So just try and become more generally educated. You won't have an opportunity to do that quite as easily, nor as much time once you graduate. So
I would add too that when you start looking for internships and co-ops and maybe job opportunities either out of high school or when you graduate, is as part of that job search, you know, look at the jobs that you want to be at 5 to 10 years from now. Actually pull up the job descriptions of, you know, where you want to be that far off, and look at what the core competencies are on that job description. You know, do I need, you know, more experience with solid state electronic design? Do I need more experience with CNC milling, right? And you can kind of use that to guide your learning and to guide your early career selection so that you're pointing yourself in the direction of getting to where you want to be in the future.
Thank you.
All right, well, thank you all for your time this morning. I hope you enjoy the rest of your Saturdays and your weekend, and good luck at grits. So I'll hang on for a couple more minutes, but that's the end of our presentation. If any other questions occur to anyone, you're welcome to shout out. Otherwise, be well.
all right, I think that's it. I will talk to you later, Will. Thank you.
See you then. Thank you.
All right. Thank you, moderator. Bye.